Okay, so let's take a look at the rhombus. Hopefully you've gone through Geometer Sketchpad and you get some basic ideas about a rhombus. Let's do a little sketch of a rhombus as best as we can. One thing that we should do is we should make it tilted kind of like a parallelogram, except there's another key thing. There's another key feature that it has. So remember back about the list. We have parallelogram first, and then we've got rectangle, and we've got a rhombus, and those two lead to square. We talked about rectangle. Rhombus is kind of different. Okay, it's still a descendant of the parallelogram, but it doesn't really have a lot in common with the rectangle. These two have separate features. They pass those features on to the square. We'll talk about the square tomorrow or the next class after that. So some things about a parallelogram from the very first day that we did parallelograms. We talked about it being a quadrilateral, so it has 4 sides, and the 4 angles still sum to 360 degrees. It's the same idea of a parallelogram where the opposite sides are congruent, which means these two are congruent. But what's special about rhombus is that these two are also the same length. As well as all sides are congruent. Another thing about rhombus is, like these two angles, let's say this angle is 50 degrees, then we know the one across from it. Opposite angles are the same. It's the same idea through a parallelogram as it is through rhombus. And if this is 50 degrees, then the one next to it or consecutive to it is going to make 180, so that must be 130. And then if that's 130, that's 130. So it's still that same they're supplementary. Let's think of some other things. When you draw on the diagonals, they cross at each other's midpoints again. So they bisect each other. And let's put diagonals bisect each other. They are not congruent, though. It definitely looks like one of these diagonals is a lot longer than the other. That was something that rectangle had, because it was straightened out. The diagonals were congruent, but rhombus, it doesn't. There is something special about rhombus, though. These lines that I just drew in for the diagonals actually split these angles into 2 equal angles. So if that whole angle is 50 degrees, then these smaller angles in a rhombus are 25 and 25. Same thing with this one. These would be 25 and 25. This 130 angle, I think if I write it on there, it might be too messy, but it also gets split in half. So 130 cut in half, like maybe 65 and 65 for each one of those angles. So the diagonals bisect the angles of the rhombus. And that should have been something that you noticed on Geometer Sketchpad, is that the diagonals come, and I had you try to measure them to see, and it should have been able to measure those angles within there and see that they actually match up, whatever they are. They match up perfectly. I'm trying to think of another few things from parallelogram. We don't have, rectangle had 90-degree angles. That's not really the case with rhombus. Rectangle had diagonals were congruent because it was totally straightened out. This is tilted, so it's not going to have those features. Those might be the main features of a rhombus. So let's practice with some algebra. So for example number 1, if rhombus LMNO has MN equal to x plus 5 and LM equal to 2x minus 9, what is the value of x? I don't know what they're talking about without a picture. So let's draw a picture. Try to sketch a rhombus. And basically it's like a tilted square. We want it to have all the sides the same length. But we don't want it to be straight up and down like a square. Now we got to name this LMNO. So you can name it from whatever point you want, and you can go clockwise or counterclockwise. But you have to go in order. So wherever L is, you got to put M after it or before it. N after or before. It's got to go L to M, M to N, N to O, and O to L again. M, and I'm going to put x plus 5 on the picture. L, M, I'm going to put 2x minus 9. Now be careful, these are segments, so they're side lengths. So there's no 180 involved in any of this. These are side lengths. So when we look at these, we do know that the sides of a rhombus, all of them, are equal. So whatever this one is, LM, NM is going to be the same thing. LM is 2x minus 9, NM is x plus 5. They have to be equal to each other, so there has to be an x value that will make them equal to each other. I think I'm getting 14. And I think all I asked for was the value of x, so final answer, 14.